about it because I want to kind of review different things as we go. And then hopefully we'll pull it all together and get this chapter done. Alrighty. So the first thing I want to talk about is, first thing I want to introduce to you are the log properties, okay? Log, and I'll put this aside.
I think we briefly went over that, like at the end of last year.
Correct.
Yeah.
So it's a little bit of a review, and then hopefully it'll be good. Okay. So, and you'll see why we want to do it, and I'll kind of explain how that goes at the same time. So if I'm looking at the log properties, and they kind of go back and forth between natural log or log log. Okay, logarithms or natural logs. They share the same properties. So if I do it for log, you'll know it's the same thing for natural log. Okay? So I'm going to use the word log. So the first one I'm going to talk about is the one that looks like this. Okay? So if I have a log and it's written with components that are multiplied like this, the x and the y, I can actually rewrite it with something called expanding. And I bring it out to do this plus this. So literally what was multiplied now can be expanded to become addition. Okay, and we'll do a concrete example of that. So for example, the log of 2 of x plus 1 times x minus 1 can be rewritten as log 2
of x plus 1 plus log 2 of x minus 1.
That's exactly right. Okay, so I mean it's not toughy, it's good. Kind of resembles some of the other different properties we've worked with where you can kind of bring things, make it bigger. So I'm looking at that, and that's just a basic property of logs. Now, we'll use it in a minute, okay, which is kind of cool how that works. Okay, that's called the product rule. We're now going to do something called the quotient rule. Not to be confused with the quotient rule for division. Okay, so these are just log properties. So you can imagine, go ahead.
So you said the first one's product.
Product, yeah. Quotient is this one. So you can imagine if the product rule tells me to expand it with addition in between, then what do you think the quotient rule will tell me to do?
Subtraction.
Subtraction, right, okay. So it kind of comes naturally. So it's the log of ax minus the log of ay. Are we good so far? Okay, the next one is called the power rule. Not to be confused with what we do with derivatives, okay? These are just basic log rules, okay? So if I have log of ax to the p, okay. What it's telling me is anytime I have a power, like p in this case, I can take that and bring it to the front and rewrite it. So this would be p log ax.
And no other stipulations for that?
No.
Log.
Loga.
Right. So if it looks like this.
Really, they're all letters.
That's all
What you
letters.
doing that? All letters.
Yeah.
It's sentencing.
Loga.
Grammar.
So looking at this, how could I rewrite it using these powers?
2 log 3.
2 log 3, x
Right.
plus 1.
Because, and then how does that help me? Well, instead of having to FOIL it out, or instead of having to expand it out with x plus 1 and x plus 1, I could take the 2 and bring it to the front. It's a little easier to play with.
Right, you would just put the 2 in the front.
Yep, you would just put the 2 to the front,
Don't do the subtraction or anything. So.
just like so.
That's okay?
Yes.
What's the difference between logs and natural logs?
So the logs are in base 10.
Okay.
And so it's a base 10 number system. Natural logs are in base E, and so it's just a little different base. The answers come out to be the same. So we can interchange between the two.
Is one easier than the other?
I like ln because it's shorter to write.
Yeah.
Seriously, that's my preference is that.
Mhm.
Okay.
What is the 3? That's just what you would plug into the log. That's
Yeah,
the log 3.
yeah. I'm gonna show how that works.
That makes sense. Like, I don't think anybody ever explained to me why it was LN.
Yeah, it's
And
based.
now it makes sense.
It's a different base. Yeah, it's a totally different base.
Well, I understood it was a different base, but I never knew why.
Wait, so LN
So LN is natural log.
no,
yeah.
it's log natural.
Log natural.
Yeah, log natural.
Neutral.
We can be French for the day. Okay, so change of base. This is one that you're going to utilize a lot in SAT, ACT, those type of courses and those type of questions.
Mhm.
Okay, so the change of base. So I just got done telling you that logs are in what base?
10.
Right, 10, okay? Your calculator naturally does logs with base 10.
Mhm.
Sometimes you come up with a problem where your log is in a different base than 10. For example, I've used a number 2 there, I've used a number 3 there. Your calculator does not naturally do that, okay? So let's look at the calculator for a minute and let's just do log. Just do log of, let's say, 100. Now, when there's no little number there, it's kind of like 1x. You know how we don't put the 1 in front of the x?
Right.
It's the same scenario. There's a little 10 here that you don't see.
Mhm.
You don't have to do anything to. So you're literally going to type in the word log with the number 100, and your output would be there.
That's okay.
Yes.
So why did some have log 2, log 3, log
Those are
8?
different bases. So
Okay.
let me explain how that we're fixing. Like I'm going to show you
Mhm.
this technique called change of base.
Yeah.
That'll make it so you can use your calculator.
Mhm.
So when you plug this into your calculator, right?
Mhm.
What is it you get for an answer?
2.
You get 2. Okay.
That's because 10 goes in twice.
Well, let me explain how that works. It's not
10 squared.
right. So
Oh, okay.
here's how this works. You know how I always give you my grandma tricks, right?
Yeah.
So log of 10, because it's typically not written, 100, the answer is 2. My calculator knows how to do base 10, it comes naturally. And the way this works is whatever this little base guy is, to this power is going to be this number.
I'm sure.
So 10 to the second, 100, that should be what we have there.
Mhm.
Okay? Now, hear me out for a minute. This change of base thing here is something that you can rewrite it so you can use your calculator. So like this right here would be log, and the way it looks is you take log of the big thing divided by log of, in this case, A.
I think you showed us this. Did you show us this last
I did.
year? Okay.
Okay, I did. Okay, so it's log of this guy divided by log of A. Now, here's the question we have. Let's go to one that we know the answer to. Remember it was 2. Let's do this and do change of base for a moment, okay? How would we rewrite this as a change of base? So it'd be log of what? 100 over log of 10. Now plug that in your calculator. Do log of 100 divided by log of 10 and see what you get. You should get 2.
Log of 100 is already 2, and log of 10 is 1.
Right, log of 10 is 1. Why?
Uh-huh.
Because there's a little 10 down here that says 10 to what power is 10? 1.
Mhm.
Did that make sense? It's really not bad. So like, what would the answer to this guy be? Without doing your calculator.
2 to the x power is equal to 8.
What is it then?
Keep, 3.
3. So your answer is 3. So it's 2 to the what power is, what's that?
Do we have to like show our work, or can, like for the Cambridge test? Okay, so we can just use the grandma.
My old grandma trick. It works, right?
Yeah.
It works every time.
But not for more complicated
It
ones.
does. It actually does.
But like if you have like a number that's not even, like
Right.
like you know like 10 to what power is equal to 17, you know, something
Right.
like that.
Right, how do I get that, right?
Yeah.
Right.
Wait, that's the grandma thing? Okay.
So, let's kind of think of it for a minute. Okay, what about something like this? I'm gonna make one up, so hopefully it works. So let's say I have log of 2 of 5 to the x equals I don't know if this is gonna work. We'll see. Okay. So, what do I do? How do I do? Right, move the x forward, right? Yeah. So take this guy and bring it to the front. Isolate the x. Okay, so then you have x log 2, 5 equals 3. Now, what naturally should we do?
Divide by log 2, 5.
Right. Okay.
Yeah.
So we have x is equal to 3 divided by log 2, 5. Well, log 2, 5 is not a pretty one, right? 2 to what power is 5? I don't know. So how do I rewrite this so I can actually use my calculator?
You do ln?
The
No.
thing, the log 2 over log 5.
The other way around. Log
5 over
log big number, log 5 divided by log 2. So I've got 3 over log 5 divided by log 2. Does that make sense? Yeah, so this it's 3 divided by that stuff. Okay? But the reason why I wanted to show you this one is so you isolate that x. You know, don't make that something that's hard to do. Okay? Now, I told you it's interchangeable with the natural log. I like natural logs better because I don't know. I just think they're easier to play with on a calculator. I don't know why. So let's talk. Oh, I gotta turn that down. So let's talk about something like this. There. Let's say I have. I have to think about what I'm looking for. 3 to the x is 5. Okay? So I've got 3 to the x is 5. Yuck. Because that's not, like, it's not 3 to the x is 9, right? And it's not 3 to the x is 27. So they didn't make it nice for me. But I know that I have properties of natural logs or logs that I can utilize. And this is where some of the properties come in so handy. Okay, so if I'm looking at this, I think I have an exponent of x that I don't want to have as an exponent. I want to kind of fix that. So look at this property over here. The property says with the power, I can bring it down to the front and be good, right? But over here, issue, I don't have the word log or natural log. So I'd add them to both sides. It's exactly right. I'm going to use natural log so you can see how it works with natural log. Same thing. So I would say natural log of 3 to the x equals natural log of 5. Does that make sense? If I did it to one side, I did it to the other, yay, I'm
Yeah.
good to go. Now, what would the next step naturally be?
Bring the x to the front.
Bring the x to the front. Okay? So yeah, so I have x is natural log of 3 equals the natural log of 5. Next step with natural, hopefully be very comfortable to us.
Divide
Both sides by, right. So we have the natural log of 5 divided by the natural log of 3. That is something you can plug in your calculator. What do you get?
So
Something.
Something.
1 point something.
Well, you know it's not 2,
Yeah.
and you know it's not 1, because 3 to the first is 3, 3 to the second is 9, it's somewhere in between there, right? The answer
1.46.
1.46?
Yeah.
Perfect. So, did that make sense? So why the heck would we learn this lesson today? Yes?
Well, I was just going to say, also alternatively, if you just recognize how log works, you could say, because you know it's 3 to the power of x equals 5, you can do log base 3, 5 equals x. And
Using the
then-
grandma rule.
Yeah.
exactly.
Absolutely.
Wait, what?
So he said, I recognize that like 2 to the third is 5, etc., that kind of thing. So if I look at here, what would I write? I have this, I have a little number, I have one here equals blank. So I have blanks, right?
Yeah.
So it's 3, little guy 3,
To the X.
to the X equals 5. Are you with me there?
Well, that's
So
smart.
3 to the X is
Yeah, that
5.
was my
Ryan.
first thought. I saw that and I
That's
was just
what I
like,
did
well, I'm just
too.
gonna
Very smart.
word problem.
Right, right. So then you plug this in your calculator using the change of base formula, which is log of 5 divided by log of 3.
Okay,
Look
what do you
familiar?
Hey.
And you get the same answer.
How did
Miss
you
Kay?
know that the 3 would be a little number?
Thank you,
Ha-
Ryan.
How did I know?
Yeah.
Because I remember it's something to a power. So whatever that little thing is,
Oh, to a power.
Right.
The base of the log is the base of the
Okay.
exponent.
right.
That makes sense.
Now, but let me show you why, because that kind of segues really, really well into something like this. Let's say I want to do a derivative, right? And I want to do a derivative of something that looks like this. Okay? As you know it right now, you don't know how to take the derivative of that. Let's review for a minute. How do you take the derivative of that?
It's power 1, so you bring the 1 down.
Okay, so let's talk about that. So you have that, you take it, so dy dx, right? This is hopefully a review.
Yes.
Mm-hmm.
1 x
1 minus
0.
1.
to the 0. So the answer is 1, right?
Yeah.
You can bring that power down for derivatives if it's a number. If it's squared, if it's cubed, if it's the fifth, if it's whatever. But if it's an x,
It's gonna be the same.
Because you
You
can't
can't.
subtract.
you cannot.
X minus 1.
You can't.
You can't.
So, the rule that you would use is very similar to what I just introduced here. It says to me, I have an x that's a power that I don't want to have as a power. Did that make sense what I just said? So what would I do to both sides?
Log.
I natural log. Because, okay, here's another reason why I natural log. Because I'm going to teach you in a minute the derivatives of natural logs and the derivative of log log. And the natural log is so much prettier. The log is just a little ugly. It's complex. So natural log is where I kind of fall into, naturally I fall into the natural log. Okay,
What are they?
What's the power or the base of natural log again?
E,
Oh, it's just, okay.
2 point something,
Okay.
17 something. Okay, so, and I haven't taught you how to really do the derivative of these yet because we're going to talk a little bit about it, but I want you to see the setup of it. So you guys, we all see there's an x in the exponent I don't want in the exponent. We're going to use this property right here that we talked about and do what to both sides?
Log.
Yeah, and I'm going to call it natural log because the natural log is so much prettier to play with. Okay?
So wait, which rule is this?
It's called the power rule.
Oh, it's the power. Okay.
He
Yeah,
comes
yeah,
to the
yeah.
front. Now, what would I do? Because I don't want that x as an exponent.
Bring it to the front.
Bring it to the front. So I have the natural log of y equals x, the natural log of x. Okay, leave some space because we're gonna do this problem in a minute. I wanted you to see why these properties come in handy. Is everybody okay with that?
So those properties apply to natural log as well, just.
Correct, yeah, they come interchangeably. Okay, are we good so far? Now, let's segue into the derivatives of natural logs or logs. Okay. So the first one is, and I have to say, this means take the derivative of, if you can recall. And I'm going to start with e to the x. Yeah, why e? Because it's the base of natural logs. So they kind of come interchangeably. Okay? The derivative of e to the x, okay, that's what that's asking me, is, going to blow your mind, e to the x.
Wait, what?
Yeah,
Wait.
because nothing is as it seems.
The first thing is somewhere.
Life is me.
We don't have to do anything.
Thank you.
Let's see why. Let's see if we can figure this out.
Miss K?
Yeah.
Doesn't also like log, they have like a function like on an XY graph?
Wait, what is?
Log of X.
Yeah, that's a graph.
Oh, it is?
Are we going to work with that
No,
sort of thing?
not much.
That's more complicated.
No, it's just not something that I'm gonna test you on, so I wanna,
Mhm.
so let's look at this. Let's say I say y is equal to e to the x. Right?
Mhm.
I hate doing this because I don't know if it's gonna make sense yet. Okay, so what did I just show you? We're proving. That's why I hate to kind of go that route because it might have, we're proving something. What?
That the derivative of e to x.
Is e to the x, right? I gave that to you, but you guys are like, why? So let me show you why, okay? So I don't want x as an exponent. So what am I going to do?
Log it.
I'm actually going to natural log it,
Sorry.
okay? What would I do next?
With the X.
Move the X to the front.
Okay. So far so good.
Divide by
Now, segue for a minute. Let's come back here. I got one thing I want to show you. The d of a dx of the natural log of x is 1 over x. So the derivative of natural log of x is 1 over x.
Miss K?
Yeah.
So,
So why isn't it dy over dx?
Yeah,
It's
that's
just
what I was thinking.
The examples that I'm showing you don't have y equals.
Oh, okay.
So if I told you from the beginning y equals ln of x,
mhm.
dy dx is 1 over x. Does that
Yeah.
make sense? So I'm giving you like the derivative of this
Mhm.
before it's an equation is that.
Mhm.
Does that make sense?
Yes.
So the derivative of natural log of x is 1 over x.
Mhm.
Back over here for a minute, okay? So if I'm looking at this thing, it's the natural log of y, right? Wait a minute, back up over here. Let me show you this. The derivative of the natural log of u
What does that mean?
is 1 over u, looks familiar, right? Times du over dx. Let me have you soak it in for a second.
What is, what's U correspond to?
Okay, so tell me what you think I just wrote. Let's compare. So you see, what's the difference between this and this?
There's a U.
Okay, so it's a u. So that means it's any other thing than x.
okay.
Mhm.
Because what's the derivative of x?
1 over X.
Yeah, it's 1 over x, right?
Yeah.
And I would put dx over dx beside it.
The
Does
derivative
that
of,
sound familiar from last year? I
Yeah.
took the derivative of x with respect to x. What is dx over dx equal to?
1.
So do I need to write that there?
No.
No. So we just naturally don't look at it.
Okay.
Yes.
1 over X is the same thing as X times negative 1, right?
yeah.
Yeah. Yes.
I just want to make sure.
What is u?
Okay, I'll show you.
Like, I can't do this if it's arbitrary. I need some meaning behind
What
it.
is u?
U substitution.
It is really.
It is?
Like, yeah. So let's do the derivative.
What is u?
I'm a little.
What are you?
Okay. So the derivative of the natural log of x is 1 over x by definition. Do you guys agree with me?
Yes.
That's kind of like a given.
Yes.
How did this change?
Good 1 and 2.
I made a 2 in front, right? Right?
Me too.
So, what about this? How did that change?
There's 3 of them.
Okay. How does that change?
Squared it and added 1.
Okay. This is u, this is u, this is u, because it's not just plain x.
Okay.
So it's anything that's not x,
Anything that's not.
okay?
I
So-
can do that.
Would it be,
So-
would the U be the 2x or just the 2?
Correct. So what would the derivative of this be? 2x.
Okay.
So, yeah? He just asked me a question, I answered yeah.
Yes.
All the above, no? Okay, so how do I take the derivative of ln of x? I take 1 over x, done, right? Let's take the derivative of this guy. Well, it's going to be 1 over 2x and then times the derivative of the u. In other words,
So it's kind of like,
du over dx. So what is a derivative of u? 2 times 2. What's the answer to this guy?
1 over x.
There it is.
that's beautiful.
Let's do another. We'll practice a few. So let's look at this guy.
Just give me a second, let me write it.
Wait, what is the 1 over 2x?
Is it always gonna work out like that?
We'll do this one and you'll see that answer.
Miss K?
Yeah.
So where did when you multiply by the 2, where did that come from? The ln of 2x or the 1 over 2x?
Okay, so I take this and put it under 1, and then I take its derivative and attach it to it.
So it's really just the number that's in front of the x.
Yes.
And so for the other one, it'd be 3.
So let's look. It's going to be 1 over 3x times 3.
But why do you do the 1 over 3x?
Because by definition, it tells me the natural log of x derivative is 1 over it.
Oh, okay.
Okay?
And then,
So-
but with the,
This one's going to be a little different.
I was gonna say, they keep canceling out, is that just because it's only a coefficient?
Correct.
Okay.
So what is the derivative of this? It's going to be 1 over x squared plus 1 times
2x.
2x.
What about the end?
Yes.
That's,
What about what?
The end. You don't do. Oh, that's what it's on.
The
the
d-
one
Oh,
could
I
just
thought
go
that
away
was
when you
a-
derive.
I thought
Right.
that
It
was
doesn't have,
the
it
end.
doesn't have variables.
Wait, because the derivative of 1 is 0.
I didn't realize that said ln. I thought that was a parentheses.
2x.
Is it now?
Yeah. Okay, that makes more sense.
Are we good so far?
Yeah.
Yeah.
Okay, let's do it.
Foil out the bottom. Foil out the bottom.
You don't have to.
So 2x over
Please,
x
Leslie.
squared plus 1.
Yeah,
And that's the answer?
that's it. Let's do another. So, a lot of times when I'm teaching calculus, I never introduce the basic. I always just introduce this guy. Because this is one scenario only. This is every other scenario. And it always confuses. I second guess myself every year.
So as long as the x is to the first power, it'll equal 1 over x.
Right,
Oh, yeah, because there's a well,
Because
unless
it's-
you're adding or subtracting something.
right.
So it's only if it's just
Well,
a
if you're
coefficient.
adding and subtracting just a number, it goes away.
Yeah, but it's still.
Oh, then it'll have the bottom,
Right.
right.
Cancel out.
So let's do,
So it's some n to the x,
Explain the x.
ln n to the x is going to equal 1 over x.
yes, always.
Okay.
Spend your whole money.
That's a solid baseline that I can remember.
Okay, how about that guy?
Oh.
Well, ln of x cubed plus 2x minus 1.
Is it 1 over
It's 1 over it times,
3x squared plus 2?
Yeah.
Oh, okay.
that's it. So it's 1 over it, whatever it is, times 3x squared
Plus,
plus 2.
You just leave it like
Miss
that?
K?
Yes.
Are sines and cosines and tangents going to come into play with logs?
Yeah.
Oh, that's going to be ugly.
Not yet. Okay, so, and then you kind of put that on top of itself, right? Do you notice that what this is basically is the derivative of the this guy with its derivative on top?
Yeah.
That's
Do you
it.
see that? Does that make sense?
Yeah.
So it's this guy with its derivative on top. Keep that in mind for later. Okay?
Wait, so what happens if that had, if that whole x, the third plus 2x minus 1 was squared?
What would you do with the 2 then?
I just move it to the front.
Right.
Oh, like the
Move it to the front. Right, exactly. That's why the properties are important, because when you move it to the front, it's less work when you take the derivative. Yes? Question?
I don't even know what I was gonna ask.
You don't even know?
Ryan's getting confused. This is not looking good for any of us.
This guy.
Why does the log thing matter here? Just because you need to know that rule? That's what happens when
That's the rule,
a log.
right.
So just cause.
Just this, it's,
What is log?
Someone smarter than us a long time ago figured this out.
it's a different base of numbers is what it is. It's
Wait,
just-
so instead of like going
It's like
1, 2,
taking
3, 4, 5, 6, 7, 8, 9, they go like.
No, okay, but you know what they use logs and natural logs for? Let's give you some scenarios. The natural logs most especially is like population growth and exponential growth and bacterial growth. What do we know about bacteria? You put 2 in a petri dish and what do you know what happens within 5 days?
They multiply.
And how, like, by astronomical, right?
Yeah.
So the way that they grow that big relates to the exponentials and the natural logs. So it's utilized and also utilized for decay. So, for example, the bones that are buried, the decay of them. So those are the kind of the things that we do with those. Yes.
So it's like normal distribution, where it's a mathematical thing that describes a pattern that
Right.
keeps appearing in real life.
Right.
Gotcha.
Right. Yes.
Shortcut.
So if there was like a squared outside that, you would bring the 2 to the front. Would you distribute it in? Or would you
Okay, so
just-
that's a question. Yeah. So like, there's a 2 up here in the beginning.
Yeah.
I would have pulled the 2 to the front, did my magic, and then just put the 2 in front, like carried it for the ride, like we did last year
With the chain.
with the chain.
Oh, wait, so the
Okay.
2 wouldn't be on the bottom?
And no, it would actually not. It would be like 2 times that.
Oh.
Because it would be on the other side there, and then you just bring it
Oh,
on
so,
top.
Yeah, it's like the number that went for the ride, and then you just stick it in.
so the 1's only on the top because it's 1 log. Thing.
Right.
Oh, okay.
Right. Okay, now, let's do this here. So let's talk a little bit about what we did a second ago. We started here, we said y is equal to e to the x. I said, oh shoot, I can't take its derivative because it has an x as an exponent. You all told me, take the x and bring it to the front.
Yes.
I did. That's exciting, okay? So now I have the natural log on both sides, yes? Right? Let's start over here, because it's a little bit easier. I'm taking the derivative with respect to x, like normal. So, tell me for a minute, what is the derivative of the natural log of x? I mean, back up. What is a natural log of e? Put it in your calculator. Ln-E.
How do you have an E
I don't know
symbol?
why there's letters.
There's actually an e, a button on your
Where
calculator.
is
I have
91?
e to the s.
Yeah.
So, this little guy right here, we don't see it, it's e.
E.
Remember log was what? 10?
Yeah.
This is e. So,
So-
e to what power is e?
0.
1.
1, sorry.
So close to 1, but yeah, 1, right?
One off.
So does that make sense? Is this whole guy is really just 1?
Yeah.
Natural log of e is 1. So let me rewrite this. The natural log of y is equal to x, 1x.
Miss K?
Yeah.
So is it really on the other side x times ln sub e e?
Yes, but we don't put sub e.
Yeah,
No different than I don't put 1x.
right.
Okay? Now I want to derive. I want to take a derivative, which brings me back to what I started to teach you a second ago. Let's work on the right-hand side. What's the derivative of x? There we are, 1. So 1. Are we good?
Yes.
No harm, no foul. We're good, right? So far, so good?
And then
So,
ln to anything that's not x.
But yeah, how do we take a derivative of ln of anything that's not x?
Put the derivative on top of the actual thing.
Okay, so I have 1 over y. So far, so good? And then times what? How do I say the derivative of y?
dy over
dy over dx.
Yeah.
Good. dy over dx. Ooh, we're on a roll.
The derivative of y.
Did we take the derivative
multi-
of x?
Say it again.
Did we take the derivative of x?
Yeah, what's the derivative of x? 1. What's the derivative of ln of y? 1 over y. Tell me you did it with respect to x. dy dx.
Miss K?